Okay, what we're going to try to do here is something called the first derivative test to find local maximums and local minimums. We'll do the test first, which is we've actually already been using it while we're graphing. We just didn't talk about that. And we'll draw the conclusions and see what we can do. Now, how does the first derivative test work? It says find all the critical points. Well, what are critical points? Those are the places where the derivative is equal to 0 or is undefined. The reason I like to write the derivative as a fraction is because I can find out when there's 0 by setting the top equal to 0. I can see when the derivative is undefined by setting the bottom equal to 0. And so I can see I have two critical points, right? X equals 2 and x equals 0, like that. And now we make a sign chart. That's what the first derivative test tells us to do. So I'm just going to come down here, kind of move this up a little bit. Remember, these are just x values. I'm supposed to put 0 here. I'm supposed to put 2 here. I do like to actually plug them both back into the derivative, so let's see what happens. When I take 0 and put it back into the derivative, it's undefined, and I have to cross it off when it's undefined. When I take 2 and I plug it back into the derivative, I get 0. And just like we were doing before when we're making sign charts, this is exactly what we do. What I need now is I need an x value less than 0 that I can plug in. I'm going to pick x equals -1, but anything that has a nice cube root would be fine. The bottom's going to be negative, the top's going to be negative. That's going to make this whole derivative positive over here. I now need a nice number between 0 and 2. I like to put x equals 1. And remember, put a box around this to tell everybody that that's a test value. When I plug a 1 on the bottom, it's positive. When I put a 1 on top, I get negative. So I get something that looks like that. And now I want to plug in a number that's bigger than 2. It's not that bad, but I'm going to pick x equals 8. Although I don't think we have to think that hard. When I plug in x equals 8 on the bottom, I get 2. On the top, I get positive. So I get positive. Now, what does that tell us about the function? Let's put a little f for function over here. This says the function's going up, and the function's going down, and the function's going back up again. And we can get good conclusions from this. Now, I'd like to say that f has a maximum at 0, but way to the right, it might go way up there. So I can't say it's a maximum. What they call it is a local maximum, which means it's higher than any point that's close by. And so we'll say f has, how about a dot, a local max at x equals 0. And the sign chart just tells us that. Now, again, I would like to say that the graph has a minimum at 2, but way to the left, it could go way down. So it doesn't have to be the lowest point on the graph. It just has to be lower than points nearby, and that's what we mean by a local min. So I'm going to call this a local min. Local min at x equals 2. And we've successfully used the first derivative test to find the critical points and determine whether they were local high points or local low points. By the way, if you don't want to say high maximums or high minimums, they'll say extrema, which is just sort of encompasses both.